QuantSpeak, expert insights from quants for quants.
Welcome to QuantSpeak, a new podcast from the CQF Institute at Fitch Learning.
Hi, I'm Dan Tudball, editor of Wilmot Magazine, and this is QuantSpeak. Reinforcement learning seems to be everywhere at the moment. The last episode of QuantSpeak discussed it with regard to building AI-powered smart portfolios. To recap, reinforcement learning is a machine learning approach concerned with solving dynamic optimization problems in an almost model-free way by maximizing a reward function in state and action spaces. This property makes it an exciting area of research for financial problems. Now, to reinforce that point, cue apt sound effect. Today's guest, Sonam Srivastava, will be presenting a CQF talk on deep reinforcement learning for asset allocation in US equities. Sonam, who is the founder of Wright Research, an India-based robo-advisor, will look at long short-term memory networks, convolutional neural networks, and recurrent neural networks, and compare them with traditional portfolio management approaches like mean variance, minimum variance, risk parity, and equally weighted portfolios. Welcome, Sonam.
Thanks for having me.
I know it's great to have you here. You described the motivation for creating data-driven portfolios as coming from a deep passion for quant finance. What are the roots of that passion?
I've been a math geek all my life, and I studied engineering. I studied chemical engineering, but I was always back in 2006 to 10, and I was very passionate about algorithms. Right. I started my career with chemical engineering, but I quickly explored, and I tried doing tech, but that didn't fit in for me. But once I found quant finance, right, I started working on trading algorithms. That really sort of clicked for me. I could see things that I was good at were making money in the market, and I had the tools to enhance and improve those algorithms. So I really got hooked onto that in 2012 when I was sort of working with some fund managers from AQR who had actually come to India to set up a quant shop. So that was my first exposure to quant, and since then I've been in the field. And in India, actually algorithmic trading itself sort of started in 2010. So me being an early adopter to it, I sort of got to experiment and work with very interesting teams here in India, build the systems ground up, and that led to my passion. I moved to HSBC where I worked on factor strategies and some other differentiated stuff for the global markets, which again really took my passion to the next level, where I explored the factors that affect the market. And I keep on experimenting with machine learning in finance. I used to do a lot of blog posts and things like that before, which led to dedicated research that I pursue along with what I do at Wright Research now. So Wright Research is actually a way for me to take my deep passion for quant finance and create something in India which is not there, right? So quant is not present in any significant percentage in India, but the India market is growing at a very rapid pace. So I saw that there will be a space for quant in this market, and that's what I'm sort of pursuing here. And it's very interesting, right? The stuff that we're doing and how people are perceiving it.
Although you say that quant is not widely dispersed in India, the Indian Institutes of Technology have quite a reputation for toughness and rigor.
No, that is true. So it's not like Indians are not doing quant, but Indians are doing it for foreign companies, right? They're not doing it for the India market. So I mean, the biggest quant team that I worked for was in HSBC, where we were working for the European market, right? Not specifically for the India market, which is a growing space.
Yes, so you mean as a localized for local shop rather than international firm?
My intention is to not be localized, but there's a lot of opportunity in the local space, right? Because everybody who is doing asset management in the local shops is very traditional, stock pickers, passive. So there's a huge opportunity for, I think quant to do well in an emerging market like India.
Absolutely. Actually, the question I wanted to ask you about the IITs was, with their reputation for toughness and rigor and so on, do you think this worked well in the development of a quant practitioner mindset? You came from an IIT background in engineering, chemical engineering. Do you think the rigor and the toughness of the program really helped develop the right mindset for quant practitioners?
IIT is definitely a place where you can really work on your skill set, work on your if you like data science, then you can do a bunch of data science courses and really excel in that. If you like algorithms, then you can do that, and it's a great place for people to sort of hone their skills. So not saying that all good quants come from IITs. I've seen good quants from across the board, even in India. But IITs are definitely a great place where people can go and really practice those skills, have some very great instructors, do some good projects, and become confident in what they're doing.
Were there any particular insights that you picked up at IIT that you've carried with you throughout your career?
I was a chemical engineer and I sort of did not like chemical engineering at all initially. And then I sort of switched to numerical methods in chemical engineering in my third year in college. And I did some projects on biochemistry where we were trying to find those siRNAs that could detect Alzheimer genes, and we were doing this using machine learning. So this was an immensely interesting topic for me. I was getting to use algos and data. So I pursued it for a couple of semesters. So I think that really made me very confident that I can really pursue this and this is my passion, right? So obviously I got that opportunity because such projects in India are mostly there in the IITs, right?
Absolutely. I think if somebody could come up with a machine learning AI project to actually replace governments, I think that wouldn't be such a bad thing. I think we'd probably end up with a fairer portioning out of public funds and so on. It can't be worse than than what we get in most countries, can it?
Could be.
You worked for a number of firms before striking out on your own. You touched a little bit on what the motivation behind this was, but what were the factors that influenced you really to go it alone and set up Wright?
So when I was working at HSBC, I was working in the central desk book desk, which is a proprietary desk on the broking floor. So when I was working there, the team sort of got shut down because HSBC wanted to not do risk trading, right? So I mean that was the motivation of me moving out of the bank, and I sort of joined a machine learning based advisor in the US called QPlum, which was again a very interesting startup started by my seniors from IIT who had done really well for themselves in high frequency trading and stuff like that. And they also sort of shut down on 8 months of me joining. So having seen these two things, I thought I want to pursue something and I want to do it for the long term. So it's best that I pursue it on my own instead of going to other places and not being able to pursue something for the long term. And I saw there was a huge opportunity in India. The new investors in India are actually the tech graduates, right? The software developers are the people who are making money in India, right? The software entrepreneurs, the software developers. So people know and understand tech and data better now, and they're looking for advisors who can give them research-based, data-driven advisory instead of the traditional passive way. So I think that was a good motivation to start. Once I started getting a good feedback from the customers, seeing the growth, really hooks you on, and it has been a good journey for me that I aim to pursue.
Do you enjoy the running of the business aspect of things as much as the quantitative aspect of things? Because we could call you a quantrepreneur, really, couldn't we?
I do enjoy the business aspects quite a lot. In the business of asset management or any quant strategies, the business at the end of the day is always correlated to, how you perform. Because the client is not a fool, right? They will just go if you're not performing, right? So this business, you have to be on top of the quant or the models that you're running so that you do well. And I really enjoy the business aspect also. We do content marketing, we do social media, we do a bunch of different stuff. We are raising capital, so many different things are going on, but it gives me a greater control on how things will go, how I want them to go. And we can create like a dedicated quant team here instead of being in a larger team and quant being a very small subset of it, which doesn't get attention, at least in India.
That's a good goal to have. Well, as I said in the introduction, reinforcement learning seems to be everywhere. In fact, on our last edition of QuantSpeak, we had Samit Alawat in to talk about reinforcement learning for building smarter trading strategies. And he had built two. One was based on hidden Markov models, and the second one was based on reinforcement learning. Now, as far as the asset allocation problem is concerned, that you're applying reinforcement learning to, can you frame that problem as you see it for our listeners?
Yeah, so the problem statement that we are going for is asset allocation problem, which I think anybody who's creating a portfolio sort of tries to solve that problem, right? That you have a bunch of assets, or let's say a bunch of stocks or ETF where you want to allocate to, and at different times you want to tactically shift your allocation, right, depending on the market conditions. So a traditional manager sort of goes with his conviction, whatever his analysis is. A quant manager would try to create an expected return and a risk function, right? That's how people approach this problem, right? And there are various methods of doing it which are quite well known, which you mentioned. One being the equal weight, where you just take the assets, give them equal weight. One being minimizing the variance. One being risk parity, giving everything equal risk weight. Or mean variance optimization, where you're actually trying to maximize historical returns and minimize the risk. And machine learning actually has been used in this framework widely, right? So if you read a lot of literature, you'll find that people have been using deep learning, machine learning models to forecast returns, right? To forecast what the return of the particular stock in the next period would be. So this is usually done using supervised machine learning. And I also tried doing that quite a lot. But the problem with that is that the market itself is very noisy, right? So if you have a simple prediction model that is trying to forecast returns on a daily basis or whatever frequency, it will give you very noisy results, right? So you will be doing a lot of churn, which will bring up your cost, take down your returns. So what we wanted to do is we wanted to explore. So in this framework, what really works is an agent who is trying to fit into the market and maximizing the portfolio performance, right? So we thought that a reinforcement learning agent could fit really well in this problem statement. Reinforcement learning agent sees the market. Based on the market, it tries to maximize the portfolio performance, and then it receives the feedback from the market, which tells us if it is doing well or not, and it optimizes itself to do better, right?
In finance, it's very important to know your weapon. There's some situations where you don't really want to use a hand grenade, where something more subtle would do. So when it comes to choosing the network type, I guess, what sorts of situations are more suited, would you say? I mean, are long short-term memory networks more suited to a particular situation, and convolutional neural networks better suited to something else, and recurrent neural networks better suited to something else again? I mean, is there a sort of a more fitting application for each approach?
So we did in our research, we've actually tried all these networks, right? In the framework that we built, right? Just replacing the network type with a convolutional or a recurrent or a LSTM. And all of these models, have a varying performance in different market conditions. But we actually did find one particular model that did well across all market conditions and sort of did better than all models that we tried out, right? So what we tried to do is, we're not just trying to maximize the performance, but we also want to maintain a healthy diversification in the portfolio. We want to have a good Sharpe ratio, and we also want to keep our churn low, right? There's no sense of doing excessive churn and creating a very undiversified portfolio, because that will lead to a lot of risk. So we saw that, our approach was actually using just a model, and we did not tell that model that, uh, that portfolio allocation is a function of return and risk, and this is what you have to do. We just supplied the data to the model, and the model saw the return of the portfolio based on the weight that it threw out, right? And the model itself optimizes itself so that, it is actually doing all the three things, which is maximizing the returns, lowering the risk, keeping the cost low by itself, which was, I think, an amazing thing to see.
Can you describe a little bit the differences in the approaches with, say, long, short-term memory, convolutional, and so on? I mean, what are the sort of defining characteristics?
So each of these three models have their own set of their own architecture, right, which differentiates them, right? So a convolution neural network is mostly used in image recognition, where you have different convolutions that try to capture a certain part of the picture, and that's how they work. So we did try convolution neural networks first in this problem, and we got we got good results with that. But because this is a sequence problem, right, the current result is actually a feature of the previous result, right? There's not a static thing. So that's why for this time series problem, a recurrent neural network, which actually has some sort of a memory, right? Because it uses the historical prediction data in its training, that would have been a better fit in this particular problem. And then LSTMs are another version of recurrent neural networks, where you actually have a long-term memory, right? So they have these gates in their architecture which help them retain a longer or a shorter term memory based on how it gets optimized. And that is again a solution that works really well in time series problems, right? So that's what we tried. But apart from these networks, right, our architecture also had a few nuances, right? That we were not just putting a network, supplying it input, and letting it give the output. We also constructed in such a way so that it has some sort of memory of the previous weights that it has thrown out, so that it can control its churn. So that was a very good feature that our architecture had. And also, when you're training time series data, then it doesn't make sense to train the model in the future and test it out in the past, right? So you have to maintain the sequence of time when training it. So that was also a feature that we incorporated in our model, so that it maintained the sequence of time when we got it trained.
How long did it take to develop everything?
I mean, I had actually been tinkering with this particular problem for some time, and I was experimenting it with some slightly higher frequency data. I read a very good research paper by these Chinese researchers, and based on that, I was sort of experimenting with it. And then Dr. Mikel Alonso, I collaborated with him on some other projects, and then we thought that let's do this for US equities and see how it goes. So obviously it took a few iterations, right, to get it right. The networks take a long time to run if you don't have the best computers in the world. So it takes a day or so to iterate over the whole history with these heavy models. But we would run it, and then we would analyze it, right? What is it doing? Why is it doing this? And if we saw that something is not going correct, we would go and change stuff. Yeah, so it took a few months for us, and then we wrote the paper that we wrote quite comfortably. We spent time in doing the literature research, doing the math research that we wanted to put into the paper. So it was a very interesting thing. I really enjoyed doing this.
How have you found the acceptance of machine learning in the finance industry in India? Do you still need to sell the merits of the approach, or is it fairly well known?
See, machine learning is well known, and sometimes it is actually used as a buzzword here because people sometimes don't understand it, but they like the term machine learning. And if you add it to your what you're offering, people get excited about it. There are few people who are doing it, but there's a lot of interest among people. It's a lot of younger generation kids who want to learn this stuff, and I get a lot of requests from people asking about it. So I think there will be a good amount of talent that would develop in the future here.
Right. And from the research and from this experience of looking at US equities in particular, have you identified where you're going to go next with your research?
So after doing this project, we actually, like me and Dr. Mikhail, have collaborated in a couple of other areas of deep learning, which are very exciting. So our one paper that we published was on double descent in time series, which is, we said that bias variance trade-off that people talk about. There's some researchers who have said that overfitting will give you a better solution. So we tried to test that out, and we published a paper on that, which was a very exciting, interesting area. We want to compare a deep learning model with other machine learning models that work really well in time series, and we want to experiment with those stuff. We are thinking about doing more research in reinforcement learning in other problem areas, not just portfolio optimization or tactical asset allocation, but other areas, right? Be it or derivative pricing, be it market making, be it anything, right? So we are sort of looking to find out interesting topics.
Great. Is this the first time you've come across the CQF Institute? Actually, Dr. Mikel Alonso is involved with the CQF Institute, and this is the first time you're speaking at the Institute. But what's your impression been of the course, and have you had a look through the program and all of that?
No, definitely. I've been aware of CQF Institute for a long time. And I think there's a community out here in India also, right? There's a India chapter and people who pursue it here. And I've seen through the curriculum, and it looks really interesting. I did another course in quant finance a couple of years ago, which was a 2-year course. So I sort of thought that okay, I'm done with the studying part. I like to experiment and do a lot of projects on my own, and I'm sort of trying to pursue the research aspect, right, more actively.
Which leads us to what's going to happen next for Wright Research. I mean, what's the direction? I assume you're going to keep with the robo-advisory business model and all of that sort of thing, but the underlying foundation of it could really take you anywhere, couldn't it?
Yeah, so we have good plans, right? So obviously the robo-advisory side of business is growing for us, right? So we want to perfect it, we want to expand it, right? So right now we actually have around 10,000 active subscribers who use our strategies, and we want to expand that reach even bigger. We want to go into a little bit of institutional capital management, right, which is a little bit more serious quant, right, because retail audience doesn't sort of care about the quant aspect, right? They want to see the return and the risk. So we want to do a little bit more serious institutionalized asset management, where we actually can showcase the quant work that we are doing. We want to do equities, derivatives, stuff like that. We started US based portfolios also. We're looking to collaborate with global firms and expanding the global reach also. So we have a lot of interesting plans, and right now I am really focusing on expanding my team, right? Because we are growing, so we need good tech people, we need good quant researchers, we need good people in the business side.
You can certainly advertise your your vacancy here, and hopefully the CQF certificate holders will get priority for interview.
Yeah, those guys, I mean, I think a CQF holder would be a perfect candidate to come in. So we are actively looking for, a CTO or somebody to lead the quant function. So somebody from the CQF Institute would be actually perfect. So definitely anybody listening should reach out.
Any final thoughts?
The research that we have done, the problem statement that we're solving with the approach that we followed is a really interesting one. There are so many nuances that that really fascinate me. And the results are also very good to look at. So I think it would be an interesting talk for people to see and start working on, get an inspiration from, and start working on their own. So I would ask all the listeners to come in and listen to the talk that's coming next month.
Brilliant. Thank you very much, Sonam. So Sonam Srivastava will be delivering a talk on deep reinforcement learning for asset allocation in US equities on Wednesday, 11th of May, 2022. It's an online global talk, free for CQF Institute members. So once again, Sonam, thank you so much for your time, and we look forward to your talk.
Thank you for listening to QuantSpeak. Don't forget to subscribe and do sign up to the CQF Institute for more insights into quant finance.